Okay, it's right at the top of the hour, so I'm going to start. We've got a lot to cover today. Good morning. My name is Doug Lottie. I know that in the description of this agenda it says an experts session, and you're expecting a whole panel of experts up here. I'm sorry to let you know it's just me and my beard, and but I am from Microsoft Consulting Services in our Enterprise Communications Global Practice, and so the experts really are a whole team of people behind me, no, not literally behind me, but back at work, that we do services engagements for customers wanting to deploy Skype for Business as their voice platform. So, but I also thought about another aspect of this. Who are the experts? And I hope in some sense that you are. This is a 400 level session. Actually, by the breakout number, it should be a 4,000 level session, but I can't go that deep. So it's deep, and I was looking at the other content, the other Skype for Business related content here, and I noticed that there is a little bit of a gap. We have a lot of feature introduction, some other things, but there's probably some of you that have not yet deployed Skype for Business and are interested in some of the lower level details of some of the features I'm going to cover. I hope you're not too disappointed. I'm going to assume, for the most part, that you've at least tried to implement Lync or Skype for Business as your voice platform. Most of these features will be somewhat familiar to you, and what I'm going to go into is what we've learned as best practices, some tips, things that have tripped our customers up in the past. So I won't be covering the whole feature end to end, but I will be kind of going broad across all the feature set. Actually quite a large number of features in this 75 minutes. Almost everything I could think of related to voice routing except for a few key areas. So if you're wondering about call via work, we had a whole session earlier on that. If you're wondering about location-based routing, I won't be going into that. I had a session at the Lync conference last year on location-based routing. You can find that recording online. There's no significant changes to date in that. But pretty much everything else I'm going to touch at least a little bit and hopefully give you a few tips. And everything that I'm going to talk about is shipping today. So there's no futures in here. This is all real. You can do this back at home. So how am I going to cover all this? Hopefully with your help. I usually like questions in the middle of my presentation, but for today, let's hold questions to the end if we have time. If we don't have time for questions, I'll be in the Skype for Business booth immediately after this session. I can answer them there. Also, I understand there's a second screen experience with the Yammer. I'll get on that later. I'll answer any questions posted on the Yammer thread related to this session. Okay? So here we go. Let's start right off with numbering and dial plans. So the whole session is about how you make Skype for Business your voice platform, right? And to do that, you need to, I'm assuming that we're going to connect this to the PSTN. In fact, here's my PSTN. I have an AudioCodes Mediant Gateway here, and this phone will represent my PSTN if we do any demos. And so you need to assign phone numbers to your users. So just my guidance on how to assign phone numbers to users. We want to, there's a field in the user settings, and I'll go to the screenshot here. There is a field here in the user settings where you set their line URI. That is the official place where you put the phone number for the user. I recommend always using a format like this. There's a plus and then a country code. This is the E164 format, but we also specify an extension here, and I'm going to describe why we want to do that when we set up that extension. We set up that extension because it optimizes a little bit of the dial-in conferencing authentication or PIN authentication on a phone. Reverse number lookup considers that extension optional, which is kind of important to keep in mind when we set up our normalization rules, which I have another screenshot here of those. Notice that my rules, when I set up in the dial plan, my translation patterns here, even though I'm using extensions for my users, I don't have the translation patterns, put those on there. You certainly could but that's just a way to kind of simplify, kind of reduce complexity where we can make that pattern easier to remember. And what I've discussed so far is this is generally for users with DIDs, but the format will look similar for users that do not have DIDs, and I'm going to show a specific example of that. So the dial-in web page still expects that a user has that extension specified in their line URI. There's no official extra field in Skype for Business where you can specify your user's extension. I kind of wish there were. So if you don't put that ;ext in there, when the user goes to the dial-in web page, they'll see this unfortunate warning that says the extension is not configured. That might alarm a user. It looks like something they should address, so they'll call the help desk. Really, all the functionality is there. They could actually probably use what they think is their extension to authenticate to a conference, but this page will warn them only because it's not in the line URI. So that's why I recommend doing it. But you don't need to put in your normalization rules. Do that by default. There are a couple of things you'll want to be aware of. If you put this in as a user's phone number with that ;ext, any calls that they make outbound will be from that phone number with the ;ext, and maybe you have a downstream IPPBX or gateway that would not expect that. We can remove those on the trunk configuration. I'll get to that, where we can translate those numbers and remove that ;ext. There's the dial-in web page. I put those screenshots in there just to make it faster than switching over to live. For users that do not have DIDs, they only have an internal extension, I assume, and it seems in most customers that I work with, they can be reached through some sort of auto attendant or a receptionist. There's a public number that can be called, and you can ask for Bob and get forwarded to them. So the format I recommend for their number is that you put that pilot number here as the base and then add their unique extension here. Because I mentioned earlier that reverse number lookup considers this extension optional, if it sees the pilot number used all by itself, it will throw an error. If you're looking through logs, you see an error code 485 ambiguous. That means that there was more than one number that matched. Usually it's an inbound call. We're doing reverse number lookup to find which user that call should be directed to. If that pilot number is used by itself and also used with some extensions, you'll get that error. And so I recommend that for that one contact or that one user that is either maybe an auto attendant or just a receptionist, you append some sort of extension to that as well to make it unique when we look across all the Skype for Business enabled users. But then, because this number will be coming in without that extension, say it comes in from your PBX, comes in from your SIP trunk, you'll need to add a rule, a normalization rule, to your dial plan that will add the extension back in just for that one case. There is an issue here on a SIP trunk where the numbers come in already with a plus at the beginning, because on the Lync server we don't fire normalization rules when the number that we're trying to translate already starts with a plus. It's just a performance optimization on the server so that we don't have to process regular expressions too often. So what you need to do is on your session border controller have these numbers sent into Lync without pluses so that Lync can then normalize them and do this. So that's the biggest thing I run into for organizations that have users that don't have DIDs. When you set up your dial plan, let me show the couple screenshots here. You can also configure an external access prefix. Now, I'll preface this whole discussion here on external access prefix by saying I don't really like using this configuration, but I describe it so that you will know how it works if your company has already configured it. The external access prefix here in the dial plan is to accommodate that scenario where a user would dial 9 for an outside line. You want them to dial 9 and then some sort of, and then the phone number, the public phone number that they want to reach. And so you want to accommodate that behavior when they move to Skype for Business. And you do that, and keep your rules relatively simple at the same time. So what you can do is on the dial plan, so I'm here in the Skype for Business Server control panel, SBSCP, isn't that cool? And I'm in the voice routing section. I'm looking at a particular dial plan. I have a field here where I can put the external access prefix. This is where you would put that 9. You would say my users dial 9 to reach an outside line. We kind of need to make the 9 optional because they won't, with Skype for Business, they won't always be dialing 9 to reach an outside line. You want to allow click to call from their Outlook contacts. And they don't put 9s in their phone numbers in their Outlook contacts. So it's always going to be optional. And the rules here accommodate that. When you put a 9 here to say this is my external access prefix, the next thing you do is you look at each of these rules. And on some of those rules, you'll check to say they're an internal extension. Internal just means this one should not be one of those that they have to dial 9 first. Okay? So there's a couple pages you have to go to. You have to put in the external access prefix. Then for some of your normalization rules, those rules that result in internal numbers, you say those are internal extensions. Then all of that configuration enables this logic described right here. All of this logic happens on the client. So it's something coded in the client, not on the server side. The client, basically, if you see that they've dialed the external access prefix, we'll remove it, and then we'll look at just those rules that are not marked as internal, right? So we don't have to put the 9 in the rule. The client will remove it before it tries to normalize. But we want to be kind of aggressive about finding a match. So if we didn't find a match there, we'll put the prefix back on, and we'll try all the rules. First internal, then the external ones, okay? The reason I start out by saying I don't really like this too much is it's sort of complex to administer. You have to put in the external access prefix and then go into each of these rules and check them. It's complex to troubleshoot, and it only happens on the client side. So if you have a gateway, maybe an IPPBX, that is coming through Link to get to the PSTN, and it puts a 9 on because it's an outside line, these rules won't work. So what I generally recommend is in these rules themselves, in this pattern to match right here, you can put at the very beginning of it a 9 question mark. The question mark is in a regular expression optional. So you can accomplish the same thing by putting it right in the pattern. And then it works on the server as well as the client. And you can see all of you can see everything at a glance there, all the behavior that you're going to get. But I wanted to make sure to cover this so that you would know if you are coming in behind someone and looking at the dial plan and you see that external access prefix is configured, this is the behavior that we should expect. All right. And one of the couple last topics just around numbering and dial plans is a behavior for off-hook dialing. So a lot of Skype for Business users will simply be using the soft phone client, the Skype for Business client on a PC and a headset. And the behavior, of course, in that client is to, in the search box, enter a full phone number and then press call, right? You don't have there's no ambiguity about the number that you're dialing. But we have IP phones, and IP phones, generally when people dial a phone, they'll take it off hook first, listen to the dial tone, and then dial the number. And the issue here is that the phone needs to make a kind of a guess about when they're done dialing and when the call should be placed. And we're trying to trade off waiting too long versus not waiting long enough and cutting them off in the middle of their dialing. So it's all based on an interdigit dialing delay. And what's happening is on that phone when you're dialing it, every time you press a button, it's seeing if what you have dialed so far does it match a rule. Have I dialed 4 digits? That matches a rule for an extension. It's because I'm doing extension dialing. And if it does, if you've paused for 1.5 seconds, I'm going to start the call. Well, that could be an issue if I've dialed 4 digits and that wasn't everything I intended to dial. I needed to look over at my notes to find the rest of the number. The phone might go off and dial. That's just something to be aware of. If what you've dialed doesn't match a rule, we'll wait 10 seconds for you to go look at your notes and finish it. And the real thing to learn about this behavior is that you should make your rules as specific as possible. If you had a normalization rule that just said 5 or more digits, just put a plus on it, then anytime the user on an off-hook dialing scenario got to 5 digits, they could only pause a second and a half between the following digits. So make that more specific. Maybe it's not just any 5 digits, it's 5 digits starting with a 4, because that's what we use for internal extensions. Or if you know the other specific rules for the area that you are in, the numbering plan that you're in, make those rules as specific as possible, simply because it will make it less likely that when a user is dialing off hook, they will accidentally match a rule and be tripped up by this short interdigit dialing delay. I know if some of you, if I were letting you ask questions right now, you would ask, is this configurable? And unfortunately, the answer is no. So this is the behavior that's built in. There's no configuration exposed for this. And address book. So we have a Lync generates, Skype for Business server generates a address book that is based off Active Directory. It takes all the phone numbers in Active Directory just in their regular phone field. They're in a kind of a pretty display format, normalizes them into that E164 format that we like. In Lync Server 2013 and back, that was based on a separate text file that you created. That text file is not used in Skype for Business server. Yay. So now you have, but it still is a separate process. So there's not like you don't use one of your standard dial plans for the address book. You have a separate set of company phone number normalization rules. Whoops, I can't draw on that screen, but I can draw over here. So this screenshot is showing a commandlet. You can do get CS company phone normalization rules. You can do new to add them by hand. But what you do need to do is right after you upgrade your first pool to Skype for Business server, you need to import that file. So maybe you've spent months and years getting the rules right in that file. When you do an upgrade, the file will still be there, but we're not going to be using it. So you will need to then do an import of that file to get the rules. It'll tell you here there's 2 rules in there. Show you those and import them and add them to the list of normalization rules. That's a global list now, so now you never have to worry about that file again unless you have coexistence. You still need it on your Lync Server 2013 pools, but every Skype for Business server pool will use this one global list of rules, so it'll be real nice. You don't have to manage that and distribute this file. It should be real nice. But we should add a note. It's not currently in the documentation, but we should add a note that says that that's a step you should take after your upgrade. Okay. Because it was related to phone numbers and phone number formats and manipulation, I thought I would add here about other inbound calls. So we can be receiving Skype for Business calls in from gateways, IPPBXs, SIP trunks. And those might be coming to us at the PBX. We're just supporting internally extension dialing. Maybe they're coming in from the PBX as just extensions. We can use the same type of normalization rules. It's not, some people have struggled in where to find that, how to apply a set of rules to a particular trunk. And that's here. And I'm in the voice routing section, dial plan. And what I'm doing is I'm making a new pool dial plan. And it sounds kind of weird, only because they chose to use the word pool in the user interface. When I pick pool dial plan, I will get a list of, actually I'll get a list of trunks that are already configured, and I can pick that. And so now you can hear, I have, for example, these trunk rules. These are dial plans that are assigned to trunks. So any call that comes in on that trunk will have these rules applied to it. And it's important to note that we apply those rules on both the calling party and the called party. So in SIP, both the from and the to. And so, for example, if this gateway were an analog gateway with analog phones connected to it, sort of like this, this analog phone then would be have its number normalized according to the dial plan assigned to the gateway. And this is for once you dig into setting up analog phone support, analog devices, you'll learn there's a contact object for analog phones, and it will seem natural to apply a dial plan to the contact object for the phone that represents the phone, because that's what we do for users. We assign a dial plan to users. Well, because it comes through a gateway first, it's the gateway normalization rules that are followed. So that's why I put this note on this page. You don't assign a dial plan to the phone contact object because its numbers are going to be normalized according to the gateway that it comes in on. Then outbound translation. I don't call this normalization, I call this translation because usually, although we're dealing with E164 within Skype for Business, when we send that out, we usually want to translate it in some way to a format appropriate for the location, the gateway we're sending the call out. If we're going out a SIP trunk, maybe we don't. But there's some things we might want to do. It was E164, but we're going out, it's a local call out the gateway, and we want to strip off the country code or maybe append some other national long-distance codes. We do all that in a translation rule applied at the trunk level. And there's a picture in here about that. So I'm still in voice routing, but now I'm in a new area, trunk configuration. And I'm looking at for this gateway, anytime I send a call out, I want to translate the numbers. And here's just something I do when I set up my demos. I do just all 3-digit dialing between the components. So even though internally I'm dealing with E164 numbers, when this call goes out to this gateway, I'm going to send only the last 3. So there's a pattern there that would strip off, just send the last 3. And so that might be something you want to do if you're supporting extension dialing between your different devices. But a couple other things you might want to do, because I recommended earlier that we use the semicolon.ext equal and then a number in the line URI format, those will make it out to gateways in a couple different cases. If we're rerouting out to the PSTN, a call that normally would have stayed within link, we reroute to the PSTN, we might need to remove that semicolon.ext. Okay, so there's some cases where you'd want to use those features. All right. So that's kind of the highlights of phone numbers and normalization, some of the things that you need to be aware of. Before I switch into some other real voice topics, I wanted to discuss for a moment location awareness and a couple things to know about location awareness, in particular as it relates to voice features. We have, as far as I can count anyway, 5 features that are dependent on the user's location. And the client reports the location, and by location I simply mean basically where in the network. It's all related to the network. And there's a couple of different ways the client, for each of these features, they get reported a little differently. And that will affect some of the things we can do with the network configuration in Skype for Business. So I'm going to spend a lot of time talking about call admission control and media bypass, not so much about these other features. But notice there's 2 differences here in how the client reports its location. For most of them, the client calculates its subnet ID, and it sends just a subnet ID. And that will be important when we're adding subnets to Skype for Business. The subnet ID that is sent then is masked locally. So the client will have a network mask, a subnet mask assigned to it, and it masks that. And those of you that have been MCSEs since Windows NT4, remember you had to take an IP exam to do that, and you did all this subnet masking and all that. And then we decided that TCP/IP wasn't that interesting, I guess, or that important for a sysadmin to know. You might have forgotten network masking. So I thought I'd just throw a simple example in here. Really, the important point is that the client is taking its IP address, masking it, doing a bitwise AND with its subnet mask, and getting a subnet ID. Sometimes the subnet ID matches on every octet, but the last. Sometimes it doesn't, depending on what the subnet mask is. So I included a couple examples there. That's important to know, because once we calculate that subnet ID, we have no idea what the client's network mask was. We just know what the result of that operation was. It's a little bit different for call admission control. Call admission control, when I'm going to discuss the feature a little more deeply, sends an IP address to a server that happens to be called the policy decision point. And that PDP does a best match. So here's a case where I know just the IP address, and I can look, Skype for Business can look in the network configuration and find the subnet that is the best match, that has basically the longest mask, right? Because we can define in Skype for Business some overlapping subnets. And because we get to put a subnet mask length in Skype for Business. So it'll find the best one, the one that fits most closely. And that means that for call admission control, if you read the documentation, you'll see that we support supernetting, or we call them virtual subnets, I think, in the documentation. But you might have subnets defined in Skype for Business that clients wouldn't actually compute on their own. It's a subnet ID that the client wouldn't compute, but could still match for call admission control. This will not, if it's a virtual subnet, a subnet that a client would never compute, it won't work for those features that rely on the client calculating its mask. So I made this table that kind of shows that. So these subnet ID exact match, we cannot do supernetting with any of those, okay? But call admission control we can. You do need to be careful about this then, because now you'll think you're relying on supernets. The reason customers want to use supernets is because you've got a whole bunch of little tiny subnet IDs, a whole bunch of little subnets serving one site, for example, but maybe if you could just define the site as one virtual subnet or one supernet, it would make configuration in Skype for Business easier, but that will only work for call admission control. So for the most part, you might want to avoid virtual subnetting altogether and just put the exact subnet IDs that your clients think they're on, okay? I think a couple of you are laughing at my little comment here. Chuck Norris, he can always supernet, and he doesn't even wear a subnet mask. All right. All right. All right. So there's one example. The main reason I bring this up, there's one example, one case where you might want to use a supernet for call admission control. And say you have a big headquarters site with a whole bunch of subnets, and you've got a bunch of little branches, kind of each with one subnet of their own, right? And you just want to control bandwidth in and out of those. And you don't want to have to define the hundreds of other subnets that you have at HQ. So you could do something like put into the sites and subnets in the network configuration. You could put, say you're using private addressing, and everything's under 10 dot. You could put a 10.0.0.0 into sites and subnets. That would, by default, kind of match everything you're using in your organization. And then for each branch, define more specifically what they're doing. Oh, they're using 10.63.42.0. And then because we do a best match, if an IP address is in that site, it will get matched to that. The others not will get matched to the broader supernet. The key point to call admission control, we have to know where both endpoints are. So if we just left out HQ, calls between HQ and the branch they would not have call admission control applied because we couldn't place both endpoints in the network map. So having the supernet for HQ will let us do that. But it does mean you might not get media bypass, for example, within HQ. So you need to balance out which set of features you want to have there. Okay, that's the introduction. That's kind of the network configuration. So let's talk in some detail about call admission control. And here's a kind of a screenshot of what you're faced with. No, that looks like the wrong picture. There's a since I got the wrong picture there, let me just switch. In the Skype for Business Skype for Business server control panel, you have down in the network configuration an area where you can define your subnets, and this is what I've been talking about here, where you can define these subnets and map them to network sites. And then you have a list of sites, but you also have these other things: regions, region links, region routes. There's a number of different objects here that you need to configure to get call admission control working. And I've seen someone take the same network and come up with 3 or 4 different valid configurations of these different, how many regions do you need, how many sites do you need. There's not generally just one right answer. There's several different configurations that would work. So I wanted to give some guidance as to how you should configure those. And I'm calling this is just me. This is not, you won't find this in any book or any web. I'm calling this the Hill method of call admission control design, all right? And it's a 6-step process. And if I gave this process to you and you followed it, I think most of the time you'd end up with the same design for the same network. Step 1, acquire from your networking team or your customer's networking team an accurate network diagram. Right? I admit this is the hardest part of the whole process, right? Let's assume you got it. My meetings usually go, can I have a network diagram? And they say, yes, we have that. We'll send it right over to you. And that starts the process of them drawing a network diagram in the background. And sometime later, I'll get it. When you get that network diagram, everything that is a little cloud on there, usually their MPLS, wide area network is shown as a cloud on there. Everything that's a cloud, draw a circle around it. In our documentation and in how we think about this, circles represent regions. So every time you draw a circle around something, when you go to configure it, you're going to create a region for that circle. Draw a rectangle around every site. Those are sites, as you'd expect. Then if you end up with these sites, these rectangles that are connected together by more than one link, they weren't shown as a cloud the first time, but now you've got some site with 2 lines coming into it. Draw a circle around that, because we need to use regions to control sites where you can kind of traverse one site. You're not using the WAN, you're using some point-to-point links to create a different route. And I'll talk about how you might handle your campus locations. Then, now that we've got all of our sites and regions identified, now we need to identify region routes and any special cases that use inter-site links. And I'll talk about those. So here's a couple diagrams, a couple network diagrams. Here's what I said. I said draw a circle around every cloud. I'm going to ignore the internet and all that. And I got a site there. I've got sites down here. This does raise the question, how do you want to handle remote workers on VPNs? And I'm just going to say remote workers on VPNs should have Skype for Business traffic blocked on the VPN, and they should be coming in over the internet. I know that a lot of you will try it over VPN, and depending on the scale of your VPN concentrators, you might have success there. But that's a topic for a whole other conversation. So here, and then these are obviously my links. So here, I don't have any sites now with more than one link in them. That's my column mission control design. 1 region, 4 sites, and I'm able to control bandwidth on each of these site links. So I can control bandwidth in and out of the cloud. Okay, that's easy, right? Picked one too easy. All right, so let's pick something a little harder. Draw circles around the clouds. Those are regions. I've already got, so this is, this up here is Chicago, building 1, 2, 3. Actually, I use this diagram even, I didn't know I was coming to Chicago to present this. So that's but they have a metropolitan area network here. So several buildings with high speed, reliable bandwidth between them. You do face a question here. Do you want to treat this as one site, or do you want to treat it as separate sites? And I have a slide that explains that. Just bear with me. I'm going to treat this as separate sites all in a region. So that's like a cloud. There's a region there. And in fact, we actually would kind of, to get to the end of the story faster, we would actually have those sites actually shown inside the region, because we don't have bandwidth concerns between building 1 and building 2. We only have bandwidth concerns on this link right here up to the cloud that connects the MAN to the cloud. So that will be a region with those buildings inside it. I have another slide discussing that. My other sites all have links between them. Notice that Cologne over here has 2 links coming in. So I need to draw a circle around that now. That's another region. Okay. Now everything is good, I think. Yep. I don't have any other sites with more than one coming out of them. These are site to region links. These Albuquerque to the cloud, London, that's a site. These that connect 2 regions are region links. So over in the control panel, we have a place to configure region links. The idea being that we only put bandwidth policies on region links. So these in the middle, I guess I could have used a different color, but that's all right. Those are region links, and then these are site to region links. So we can apply policies on all of those. For any 2 regions that are not directly connected, so say I called this region A and this region B and this region C, I have a region route that tells Skype for Business server when it's evaluating if there's bandwidth or not available, to get from region A to region C, use these 2 links. That's all a region route does. is for any two that aren't directly connected, where there's not a link directly between them, tell which set of links to use. In this diagram, it's pretty straightforward. It's real obvious, but the server does not assume that it should just find the one that works. It does require you to define exactly which set of region links you want to use between regions. Okay, so I can make this even more complex. So circles. No, I'm not going to do that. But all right, just a few considerations then. A campus. We have one of the other things that we can assign to a site is a location policy. So here's a set of my sites, and the sites are in I only have, this is kind of that simple diagram. I have one MPLS WAN, everything's connected to it. Right now, I have a bandwidth policy assigned to them. My bandwidth policy is just not very restrictive. There's a policy assigned, it's just not actually very low values. That's what I mean there. But notice I can assign a location policy to them. I'm not going into emergency services and location policies. But generally, if you're doing E911, you would want to have a different location policy per building, perhaps even per, LIS subnets you want to do by floor to get location. Policy is more about what route should I take out, who's the receptionist for that building what emergency desk should be notified if a call is made. So often you'll want to have a different location policy by building or more granular. So in this example where I have a campus with multiple buildings, then I would want to make each building its own site and the whole campus just a region. But it is possible to make the entire campus one site. And in fact, I just wanted to highlight, if you're doing location-based routing, so maybe your campus is in Hyderabad or Delhi in India, and you have location-based routing concerns, location-based routing enforces that PSTN calls can't traverse across site boundaries. So you might want to treat your whole campus as a site to help you comply with regulatory requirements there. And you'll have to see my other presentation on location-based routing. Edge, I didn't show it in any of my pictures, but we need both endpoints mapped. I mentioned that. And in some cases, we might want the Edge server to be one of those endpoints if the user is remote. And the Edge server's candidates are these public IP addresses assigned to the media relay. So that public IP address that's assigned to the media relay should be covered by one of your sites. You have options whether you want to make a new site that represents your perimeter network or just put it in the data center site. And it just depends on how important it is to you to be able to control internet bandwidth. I generally don't think that too hard about it. Just put it in the data center site. There is a special case for phone calls to the PSTN where we can have the mediation server control the number of calls going out to a SIP trunk by doing a special configuration there. That's defined in the documentation. I'm not going to go much deeper on that, but I just wanted to mention it. Regions. When I had to created a site, I had to associate a central site with it. In my link topology, wherever I have pools or front-end servers, I will have a central site. When I create the region, I have to associate it with the central site. It doesn't really matter which one you pick. I won't go into what they're used for, but in detail. But it's just controlling how we aggregate bandwidth information between the different policy decision points and different sites. So don't worry about that. If you see in our diagrams that we draw a site inside that region circle, like I did back on this one, I drew these sites inside that. That just means we don't have bandwidth concerns for those sites that are in that circle. So we didn't put bandwidth policies on those links. The ones that do have bandwidth policies on them, we've drawn them outside the circle. But really, Chicago Building 1 is a part of Region A just as much as Portland is a part of Region B. So everything's a part of a region, but it's drawn outside if we want to show that we want to put bandwidth there. Okay. Okay, good. Bandwidth policies are only ever applied to links. In the user interface, it looks like you're assigning a bandwidth policy to a site. It's a small distinction, maybe not that important. You're actually applying the policy to a link between that site and that region. I mention that because it never means that calls within that site would be restricted. So calls that stay where both endpoints are in the same site, never restricted, because the bandwidth policy doesn't apply. It only applies when they cross a link between two sites. Okay. The only, and so those are pretty straightforward. The only thing to mention is that there is a special kind of link that can only be created in PowerShell called an inter-site link. And it's great for that case where you have two sites that have a dedicated link between them that is really not routable. When we do an inter-site link between them, calls that go between those two sites will be evaluated. The bandwidth policy will be evaluated on that link. But we never traverse it, like call from site A would never go through that link. It's only used between those two. So it's probably, with today's networks, probably a rare case, but we can accommodate that in the design. Region routes, then, I mentioned earlier, anytime you have two regions that are not directly connected by a link, you'll need to put a region route between them. So you can define, like to get here in this picture from site 1 to site 2, we've got an inter-site link, we've got the site to region links, we've got a region route here that might say to use these two links. It looks like when you define this that it could be ambiguous which path a call would follow. Now, to be clear, when I say a path a call would follow, Skype for Business does nothing to control the routing on your network, right? This is all about what links will we assume that this call is traversing just so that we can account for that bandwidth. Well, Skype for Business won't let you create an invalid configuration. There will be, even though it looks like there's multiple paths, Skype for Business will always know which path to use based on this priority. If there is a site, inter-site link directly between them, we'll use that. If that doesn't exist, then the next thing would be use site to region links. And then we know that the path would be site 1 to region 1, and the regions are directly connected here by a region link, so we'd use that path. But if there is a region, whoops, I didn't mean to go that far. If there is a region route here that says to use other links, we'll use that. So there's the priority there. If there's no links, then we won't be doing a policy. If we can't map the two endpoints, we won't do any kind of policy enforcement. All right. So we've defined this network. The whole idea of defining the network is so that we can have these bandwidth reservations and control how much bandwidth the call would use and how many calls total could be on a link. The bandwidth check is done as part of the process of getting candidates for media relay on the edge server. So this is we call this ICE, and you'll find other presentations that discuss how ICE works and how we allocate candidates. All we've done is make an extension, a turn extension, that will let us piggyback bandwidth requests on there. That bandwidth request could be a check to see if there's enough bandwidth available. If there is enough bandwidth available, we'll start ringing. So what happens when I call someone, the client won't even alert the user unless it's already done the check and found out there's enough bandwidth. Then at the point the user picks up, answers the phone, we'll do a commit. We have a reservation update defined in the specification. I've seen it used occasionally, but really we could just focus on the check and the commit. What's the only thing that's really important to know here is when we do the check before we alert the user, but if the user is signed in multiple places, we don't do the commit till they pick up one of them, right? So it's possible that between the check and the commit, maybe the phone rang for 10 or 15 seconds, it's possible another call started in that same time and used the bandwidth, but the server will never deny a commit. It figures I've already rung the user. It would be kind of rude at this point if they picked up the phone and then I kind of told them, sorry, there isn't enough bandwidth after all. So they'll always allow the commit, and that's one way you might get oversubscription. And the client will has some upper limits as to what it will commit. So the conversation kind of goes like this. The client says, hey, can I have a bunch of bandwidth? That's the check. And we'll say, in the response to that check, the server will tell the client how much there is. And it might say, oh, there's no limits, there's no restriction on that link. So for a peer-to-peer call, the client will say, all right, I'm glad there's lots of bandwidth. I only need 91 for my call. That's kind of a magic number in the client right now. For this peer-to-peer Skype for Business call, I only need 91 kbps. So we'll put you down for that. That will be accounted for on that link. If we say there's 150 available, we'll say, great, I only need 91. If this were a call to the PSTN, we want, actually the number is 161. It's mentioned on the other slide. But for PSTN calls, we might need to use G711, which is going to require more than RT Audio or Silk. So we really just have these two upper limits that we'll use, 91 for peer-to-peer, 161 for conferences and PSTN. If the PDP tells us that there's only a certain amount available, either because the rest is already consumed or that's the per session limit that someone sent, then the client will grab all of that, up to 91. Okay. So the reason you use call emission control is to really, in your managed network, you want to make sure that you've got these DSCP queues set up, and you want to make sure you don't overflow those queues. I'm concerned. I think we need to. It's great to do this work on paper and find out. Well, I have 1 meg available in my queues, so I can allow 10 100K calls. And if you configure all that, my concern is that you'd actually find your queues really underutilized. So the client will request 91. This is a table from our documentation on bandwidth requirements. The reason the client requests 91 is because if we need to add redundancy to the call, then we could need up to 91. On most of your networks, you won't have enough loss. This is right, assuming the call is within your management, you won't have enough loss to require FEC. So the full stream would only be 62. So if we allowed 91, I reserve 91, I'm only use 62. And then on top of that, if we assume that you're not speaking all the time, we account for the silent suppression and voice activity detection. That call might only be requiring, about 40K. So you've got these 10 calls. You're only going to use 400K of your 1 meg on that link. So I think what we need to do is kind of watch actual usage, see how you're set a configuration. I'd hate to see calls denied by call emission control that really there was enough actual bandwidth for. So watch the usage, adjust this. You might be actually accepting some risk that if all of these calls did go active and everybody was talking and forward error correction required, you might be taking some risk that you'd overflow the queues. But I think I think you can manage that to an acceptable level just by monitoring appropriately. All right. Let's switch gears from call emission control and talk about outbound routing. Okay, I'm sorry. Can I save questions to the end? Because I'm looking at the time. Yeah. But I'll make sure to catch me if not at the end, then I'll be in the booth right after this. Okay. So outbound routing. Outbound routing. Once we've decided, so call emission control is applying mostly to calls that stay within Skype for Business. It is controlling the Skype for Business PSTN call from the client to the mediation server. But once the call is going to leave us, it goes out a trunk. So we have this logical configuration in Skype for Business called a trunk. And we can kind of, well, in the trunk, what we configure is a specific gateway to use, and the port that we want to use on that gateway, and the mediation server and the port. And we can change those. So we can have, between Skype for Business and one IPPBX, we can have many different trunks configured. Maybe we want to apply different rules, different normalization rules, different policies based on the number that's being called or something. We can define that. So I just wanted to introduce trunks here to show that it doesn't always mean, it could be, trunks can be going to the same gateway through different mediation servers. And we'll talk about, well, this is going to come up as we talk about failure routing here. So we make the trunk our destination of a route. And a route, if I go to, I'm going to switch over to voice routing here. If I look at voice routing, I have a section here for routes. And in an individual route, I have a pattern to match. So what phone numbers do I want to use that route? and then when I go out that route, which trunks. It usually looks like a gateway, but it can be there could be more than one listed there. So I get the question a lot, when I do that, when I want to control the order in which I use gateways, the preference I use gateways, I have several different options for specifying multiple trunks. So for a given number that's called, I want different options for how I route that number. In that one route I showed, it was a list of trunks. From that list of trunks, we'll just select randomly. So if I have multiple gateways listed in that route, I'll select randomly between them. That's great for load balancing. We connect, I'm not covering some of these basics, but routes are also connected by usages. And so I can actually have multiple routes with the same usage. I have a screenshot of an example where you might do that. Here's several routes. And they all have different patterns that they're matching. Because I'm doing like a least cost routing here, I want to route to the PBX for Atlanta when you dial in an Atlanta number. And so I've put them all in the same usage. They all have the same usage specified here. So generally, when we're doing something like least cost routing, we have different numbers to match. We'll put them in the same usage. So now I can say, this user can call anything that has internal extensions in it, and it will select the right gateway from that. So having routes with the same PSTN usage is great for the case where you want to do least cost routing. If you want to really enforce try a primary gateway first and only fall back to a secondary gateway if the first one's down, we need to put the routes in different usages. So I'd have a usage that's primary route to Atlanta and a usage that's my secondary routes to Atlanta. So I'd go and the usages then are ordered in the voice policy. And so depending on where the user is based, I can have different backups for them. Try the least cost route first. If that fails, try the gateways that are close to them because it's in a different usage. And there's a lot, there's a lot more that you could do there, but because there are so many options for putting trunks in routes and usages, I wanted to make sure we had that reference established. Again, that's just some screenshots of the UI. So we can do, this is since Link Server 2013, we can go through multiple mediation servers to get to the same gateway. And this is great for a number of cases. Maybe for resiliency, we want to count when mediation servers are down or when pools are down. We want to get to the same gateway. The gateway might still be up. We want a different mediation server to get there. There are some cases in PBX interop that I'm not going to go into where we want to have multiple trunks to the same IP-PBX. Now we can do that by having multiple trunks with different ports. Same gateway FQDN, just a different port on it. So that's a nice enhancement over Link Server 2010, where if we wanted to do that, we had to give some fake names to the gateway or to the PBX. And then maybe you have a SIP trunk configuration where you have mediation servers at sites all going to some central carrier-hosted SBC, and you just want to have different paths to get there. So I wanted to talk really about this with respect to routing during failures. I want to talk about inbound and outbound routing during failures. On inbound call, say we have a pool. This is an example where a pool has failed and we've failed over to a backup pool. The mediation server, this standalone mediation server that has a pool as its next hop, it understands that failover. So it will if its primary next hop is down, it will go over to the other. Outbound, you have to, as an administrator, previously configured some alternate paths for that. So I mentioned this is something you'd want to do. If your mediation server is co-located in your pool and you take that pool down and fail over, you'll need to already have routes configured that use the mediation server co-located in that other pool. Okay. So thinking about trunks and things that we can do with them. So we have these trunks off to different gateways. It turns out we can route between those trunks. So trunks, we might have one trunk configured to connect us to an internal PBX, another trunk connecting us to an SBC to the PSTN, and we support a routing between those trunks. So now Link Skype for Business Server can be like your session manager. call comes in from the PSTN over the SIP trunk. We can apply rules to that call in Skype for Business Server that would then just route the call. It's not destined for a Skype for Business user, destined for a PBX user, and just route that over to them. It lets you administer this to the same user interface where I configure routes I use for administering this. We support media bypass between those two trunks. We do all of the call authorization at the trunk level, so it's just based on the number being called. We just would route that out to another trunk. So you can, most complex organizations, have maybe PBXs per building or per campus, and they've already networked these together. Now, Skype for Business Server can just be a part of that network, right? So as you're deploying Skype for Business, maybe for just a part of your user set as their voice, you could just kind of make it fit into the routing between PBXs that you're already doing. This could be something you do, too, instead of, we've solved this. The question is, how do you route calls? You have one set of trunks to the PSTN. What do you put in front of those trunks? Well, for some customers, that's been they put a smart SBC there or a gateway that looks at the number called and routes some to the PBX and some to Skype for Business, and that's perfectly appropriate. But we have this other option now of just having those trunks go straight into Skype for Business and let it route to the different PBXs. It'd be nice if Skype for Business Server is your destination, and then you've already got it in the right place, and as you eliminate the other PBXs, you don't have to change your PSTN trunking again. All right, this is all done just by configuring usages on the trunk. I wanted to make sure that you knew that when you edit the trunk configuration and you put some usages on there, you are enabling inter-trunk routing. And I've seen some administrators just say, hey, there's a spot to put usages. I'm just going to put usages there. I'm suggesting only do this if you intend to, right? Only if you know that you're doing inter-trunk routing. Otherwise, it's perfectly appropriate to leave this usages area blank on the trunk configuration. This is a little tidbit that's new. If you were doing inter-trunk routing in Link Server 2013, you might have noticed that it interfered with your unassigned number routing. And if a call came in on a trunk and there were usages assigned to there, we would just go straight to the usages and never consider, is that a number that you've configured in unassigned numbers in Skype for Business. And so that's fixed in Skype for Business Server. If there are also unassigned numbers, it didn't match the usage to go out to the other trunk to go out, we'll come back and say, hey, here's some unassigned number. It's in the unassigned number range, so we'll play the announcement appropriate for that. So it's fixed in Skype for Business Server. You might be thinking, will it be backported? Will there be a patch for Link Server 2013? And I would say it's this way. You can apply the patch to Link Server 2013, and the patch is called Skype for Business Server because we have an in-place upgrade. So there you go. If you have Link Server 2013 and you want the fix, just in-place upgrade. There are a few slides here of the flow that show how this happened. This is a log of outbound routing. And if you haven't done logging in Link Server or Skype for Business, you should. And I just wanted to take a chance real quickly here to show now the great way to get these logs. We will have relatively soon, I hope, available as a download the Skype for Business Server debugging tools. And so this is, does this look familiar to some of you who used OCS Logger in the past? It looks a lot like OCS Logger, right? But I want you to notice a couple things about it here. It is actually controlling CLS logging. So there's a little, it's getting your centralized logging service scenarios and your topology so that it can list all of the machines in your environment. And you can control from this one GUI now, logging against all the machines. Right from the GUI. And you can define new scenarios in here or just pick from any of the existing scenarios. Pick that, start the logs, get the logs, and so on. So it's a really nice tool. Should be available as a download soon. I think right now there's another session going on, troubleshooting. I don't know if they're discussing that. These then are logs of outbound routing. And it's really just showing if we don't configure usages, anyone who calls in for a number that we don't recognize just gets a 404 returned to them that the user wasn't found. But as soon as we do assign a usage to that trunk, then we'll apply intertrunk routing to that, and it could go out a different trunk. Okay, pretty straightforward. So a few topics then on what happens when a gateway fails and you want to route around it. The first concept to understand is that there are basically two different classes of errors that a gateway can return to us. And they're those errors that we should retry, and those that it wouldn't help to retry. So by retry, I mean the gateway has reported to us that maybe all of its trunks to the PSTN were full, right? Or maybe that gateway itself was down. Well, we should try another gateway in that case, because maybe there's another gateway we want to load balance to where its trunks aren't full. So those are retriable errors. Outbound routing will know that's something I should retry. Non-retriable errors would just be, hey, we got out to the PSTN fine, but it was just busy, right? The subscriber was already on the phone, or you dialed a number that's not in service. It doesn't matter which gateway you try. Any gateway you try, the number would still not be in service, so outbound routing won't retry those. We've run into a couple cases where the gateway, where all of the trunks to the PSTN were full, reported 486 that it was busy. The gateway was busy, but not the subscriber. And that will cause Skype for Business to not retry that, when really it would be appropriate to retry that. So we have kind of a workaround for those cases. And this might help you in any case where you're seeing response codes. The only response codes we retry are 503 and 504. If your gateway or your SBC is returning something different, you can map it to an appropriate code, and that might help you route around failures. Okay. We've been making, since Link Server 2013, we've been making this a lot more resilient. We're trying to be proactive about determining which gateways, which mediation servers, which pools are up. So you'll see, if you're doing logging and you look at the SIP logs or the S4 logs, you'll see lots of these SIP options requests going around. And we've got some timers that are, if a gateway has just gone down, we don't want to wait for the 42 seconds for a TCP socket to time out. So there's just a 4-second socket timer on there that if it's not responding, we've tried to make a TCP connection and it doesn't respond, we want to fail that over as quickly as possible. It wasn't always the case. If you've done this in 2010 or you've been there for a while, there were cases where users had to wait like 40 seconds before it would roll over. Another thing, this is kind of trivia, but the mediation server might have multiple gateways that are dependent on it, that it goes through. And it has, it's kind of humble in that if it can't get to any of those gateways, it assumes maybe it's the problem. Maybe there's something wrong with my network adapter or my connection to the switch. That's why I can't get to any of them. And we do a little bit more efficient routing just within SIPStack to try a different mediation server for DNS load balancing. If it can get to at least one, then it assumes that gateway is down because I can get to others, they're responding. So it's not my network. In that case, it returns a slightly different error code. And outbound routing selects another gateways. The end result is the same. We'll just try another path, whether it's a different mediation server in the pool via DNS load balancing, or whether it just goes all the way back to outbound routing. We return this 503. So just a little bit of trivia, and not something to get too worked up about. I thought I'd throw that in there for you. What happens then when we need to reroute a call to the PSTN? So the scenario here is that two users, Alice and Bob, have tried to make a call to each other. And because of either a failure in the network between them, so they're each connected to their pool, they're signed in, but in the middle of the Atlantic there's some issue and they can't get to each other. Or because call admission control has said there's not enough bandwidth, we will reroute those to the PSTN. So Alice is trying to call Bob. I can't get to Bob over the WAN, so I'll try to call Bob by calling his phone number and then letting outbound routing find the right gateway for that number to go out. Well, if you have done least cost routing, it's quite possible that the gateway to get to Bob's phone number is also close to Bob, and maybe you can't get to that gateway either because of the same outage, right? So you'll need to have for your users, if you want to enable this fallback to the PSTN, you'll probably need to have a route to the PSTN that's close to them that they can get out when there's a network issue to place the PSTN call remotely to Bob. So I mentioned that just so you know, when you're configuring voice policies, make sure you think about using local gateways. So there's a series of ladder diagrams and flows here showing this. This is a call and mission control block where this is Alice's client. She's trying to get directly to Bob. Bob's client, before it even alerts him, has done the bandwidth check and finds out there's not enough bandwidth. So we tell Alice that there's not enough bandwidth. Actually, this is the front end here in the middle. The front end says, oh, there's not enough bandwidth. I'm not going to cancel the call yet. So instead of canceling the call at Alice's, we just send back a little message that says, this call might take longer to set up. And that's what these two pictures coming up next here shows. This is just insufficient bandwidth. But the server gets that and turns that into an alert so that Alice's client can let her know we're still trying to set that up. Now we try to place a call out to Bob's actual phone number. So this is Bob's actual phone number. We're going to try and place a call to it. And in this first example, we find Bob's in Boston, so we're going to try and call the Boston gateway probably through a Boston mediation server. And we get the same thing. Here the mediation server tells us, the mediation server is co-located in Pool B. Here the mediation server tells us that, hey, you couldn't get to Bob. The mediation server is in the same location as Bob, so there's insufficient bandwidth to get to that mediation server. So now we fall back. Outbound routing says, oh, that's just like any other kind of failure. We'll fall back to use, Alice is in Atlanta, we'll fall back to use an Atlanta mediation server for that call to Bob. So I go through that flow just to remind you that you should make sure you have backups that use local gateways if you want PSTN reroute. Okay, think about now this call is somehow it's going out to the PSTN. We have a feature called media bypass. It's like I said, we're going through kind of a survey, kind of broad and deep at the same time. We'll talk about media bypass. Media bypass is really about bypassing this mediation server role I've been talking about. This mediation server is our connection to the PSTN, to gateways, and so on. But with bypass, we can just send the signaling through that and not send all the media through it. And so the client will be talking directly to the gateway or directly to a media termination point. We just use G711 in that condition. So we do media bypass within a site where we don't have bandwidth concerns. So any given call is either going to cross site boundaries, and then we would apply call emission control to it, or it will not cross site boundaries. It will be within a site, and then we could do media bypass in our typical configuration. So that's what the media bypass feature is. It allows us to kind of simplify the topology, because now we don't have to put mediation servers in branches. Users that are in a branch can talk directly to the gateway in the branch and have the mediation server centralized. So that can reduce your overall number of servers. And it does provide a call quality optimization. That media is taking it's not taking a hop through the mediation server, lower latency, maybe a shorter network path. So we're getting a better quality call as well. So we want to do bypass as much as we can. I've included here, if you do these 4 things, you will get media bypass on. The ones that are usually missed, is that for the most part, when you do bypass directly to a gateway, you're not encrypting the media. It's possible with enhanced gateways. When we qualify a gateway as an enhanced gateway, we do support TLS and SRTP to that gateway, so it's possible that you would get that encrypted end-to-end. But if not, we need to change our global encryption option to just support encryption and not require it. Bypass relies on these bypass IDs. And I said we want to do it within a site. So a bypass ID is really kind of a unique identifier for a site. And we pass that around when we're negotiating the media path in call setup, where there's this session description protocol that is passed between the gateway and the client. And we really are looking to see, is the gateway media endpoint and the client in the same site? If so, we should do bypass. So it's a little different decision for incoming calls and outgoing calls. And I have that covered here for you. It's really just to illustrate, everybody's kind of involved in making this bypass decision. So you can come back and refer to this. On the outgoing call, the mediation server needs to make a good guess as to where the gateway is in the network topology. And if the media termination point for that gateway is not the same IP address as the signaling endpoint, because the gateway, the mediation server knows where it's about to make its SIP connection to, right? So it knows the IP address there, but it doesn't know if the gateway is going to return to us a different IP address for media in that SDP. And if it does, then we need to define that in our topology. And this is just illustrating that here for us, this alternate media IP. There is a case where your bypass IDs will all be the same, or you'll have several sites sharing a bypass ID. So it's not exactly a site identifier. If you have campuses where you have buildings that don't have bandwidth concerns between them, we will assign the same bypass ID to all those. So even though those buildings are separate sites, this is a special case where a call that does cross those site boundaries, because we haven't configured a call emission control policy between them, then we can do bypass between the buildings. Okay, a special case on that. That's why the bypass IDs are key to that, rather than just like the site name or something like that. I did want to discuss refer support. So there's two different ways to turn on media bypass. And you'll do this slightly differently whether or not the gateway supports receiving a refer from us. Yeah, that's okay. So if the gateway supports receiving a refer from us, we'll actually have bypass in more situations, in more scenarios. The way you know if a gateway can receive a refer from us is if it's qualified as an enhanced gateway. If you look on the Open Interoperability Program website, you'll see some gateways are listed as basic gateways and some are enhanced. Enhanced gateways can receive a refer from us. We can do TLS and SRTP to them so we can keep the media encrypted. Basic gateways probably can't. It might be that they only passed one or two of the things required to be an enhanced gateway, so they got listed as basic. But generally, only the enhanced gateway support refer. And on the IP PBXs, it will list actually in the notes for the PBX if they support getting a refer from us. And what's the practical difference between that and how you configure this? I just wanted to show one example real quick. This is here's Alice. She's signed in, and I'm going to run Network Monitor here, and I want to make a call to my phone. Since I brought all this gear with me on the plane in my backpack, I needed to use it for a demo. Look at that. Okay, so Alice has called this phone. This, hello? Oh, yeah, okay. What you see in the network monitor here is that I have media bypass configured. And the media is going directly from my client machine to the gateway and back. I've got RTP in both directions between the client and the gateway. At the moment that she transfers this call to Bob, Bob's probably away, but we'll see. At the moment she transfers this call to Bob, because I have right now on the, my server's probably waking up here. On this server in the trunk configuration, right now I have this gateway configured to not support refer. So I've transferred the call to Bob. My gateway is configured to not support refer. So now my media path has changed from being between the client and the gateway to the front end and the gateway. So at this point, my mediation server is co-located on the front end. I don't have media bypass on, I don't have refer on, so I'm not getting media bypass in this call anymore. I can fix that if my gateway does support refer, if I know it's an enhanced gateway, and I want to have bypass after the call, then in my trunk configuration for that gateway, I enable sending refer to the gateway here. Now, the thing I want to caution you about this is that, and I commit those, the thing I want to caution you about is that is the default. The default on a trunk configuration is to enable sending refer, and most gateways, unless they're enhanced gateways, can't support the refer. So you will probably want to turn this off. You'll get failures in the call flows like dialing, conversing, response groups, forwarding. Those call flows that use refer, you'll get failures if you send a refer to a gateway that doesn't support it. So make sure to turn it off. But if you have a gateway that does support it, leave it on because you'll get this media bypass benefit. And if what I have on the screen here is, I'm waiting for the event that says that configuration change I just made gets picked up. If it gets picked up in the next minute, I could do that same call again, and you'd see that I had bypass after the transfer as well. Now the media would be going directly between client 2 and the gateway. So that's the benefit of having refer support. But the big caution is to only leave it on if you know your gateways support it. All right. So there's the PowerShell commandlets for doing that. And there was my demo. And according to the timer, I have 15 seconds to spare. I wanted to point out the related sessions. Unfortunately for you, many of these are already passed. You can go back and view the recordings. I pulled out of the agenda those that were kind of related to phones and calling. So you can go back and view those. So thanks for your time. I could take a few questions now. Thank you. I'll take a couple questions now with the microphones, please. I'll just go 1, 2, 3, 4, and then after this, I'll be in the booth.
So for call admission control, when you don't have, you exceed your bandwidth number of calls that you can make. For users and for analog phones behind an analog gateway, what is the behavior? And can you tell if its network is down or bandwidth constrained?
So the Skype for Business client user would first, we would try PSTN reroute. They might get a message saying call may take longer to set up, but then they would get a network is busy alert. So it would say network is busy.
But it's the same if the network is down, for example?
No, if the network is down, they'll be signed off. It'll be slightly different experience.
You can tell the difference?
Yes.
And for an analog phone, do you get like a busy tone?
I haven't tested with analog phone, but I think you would get a fast busy. Yeah,
okay.
Just you couldn't set up the call.
Thank you.
Question about the if Edge is down during your PSTN call. When we try to go get a port on the AV Edge, the user gets that pong, pong, or whatever Skype for Business is playing now. How can we speed that up for them? So why can't the front end just go, hey, I see the edge is down?
This is here, you'll get a shirt for this hard question. There is an issue during call setup. We want to allocate ports. If the edge is down, unfortunately, there's no. So it's at like the top of the list of things we want to fix because it affects response groups. It affects cases where we don't do early media. So, but there's nothing we can do about it as an administrator now. Well, I can't say it's in the works, but it's like where we track things we want to fix. Yeah. All right.
Would you say that the best practice is to not have the gateway send a +2 link, so this way it doesn't see it normalized?
I would say yes. If I had to pick one or the other, I would say have your gateways, have your SBCs not send a plus into so that we can apply normalization rules in Skype for Business.
One question regarding the support of the gateways for Skype for Business. Are they supported the same as for Lync? And is it supported to have the gateway at Lync and use Skype for Business in a mixed environment?
Right. So there will be a separate list of so just like there was a separate list for 2010, 2013, there'll be a separate list for Skype for Business. Jamie Stark is the owner of that. I was talking to him. He says we're working on publishing that. So it will be, there's a list that we already know of several that will be, they are having to go through testing again, but probably the same, for most of them, the same firmware version.
Okay.
So, all right. Oh, there, I guess. You can come get a shirt.
We do some super netting, things like that. One thing, we're still on 2010, but the one thing we notice when we do virtual super netting, you don't see the site name when you're looking at the QoE reports, like the location report.
That's a good point. We use those subnets in QoE reports, and yeah, you might, because we're not matching, the subnet ID won't match.
Yeah, I was curious
anymore.
if it changes at
No,
all.
there's no change in
Okay,
in that
it's
behavior.
Still the same. Okay.
I got a couple more shirts here though.
Sure.
Is there a way to get Skype for Business to honor SIP update messages that can contain like late caller ID information or call transfer information for interop?
So there's no configuration exposed for doing that. Yeah.
Sucks.
All right. So sure. So then I think the next speaker, so I kind of want to get out of his way and pack up my stuff, but go ahead.
So for a pool to be placed on a particular site, or it should have its own site? Where should we put a pool itself?
Where the pool is itself? No, don't do anything. So when you're thinking about network configuration of sites?
The CAC admission part of it?
Yeah. So don't do anything unique for where the pool is, except just match your network topology. So if it's off in a data center all by itself and no users are there, yeah, there should be a site for that data center so that for conferencing we can control bandwidth. But if it's a site, don't make it, if it's like one building that has a pool and users, they all should be just one big site. So don't do anything.
Won't the restrictions, those are to be applied for users in that site, would also get applied to the pool?
Yes, because we'll apply these restrictions when calls cross site boundaries. So we want these users in that site to be able to get to the conference server, kind of unrestricted. Users outside, whether they're calling a user or joining a conference, should have the same, because we're concerned about the link bandwidth, not bandwidth within the site. Okay? All right. Thanks, everyone. I will be in the booth if you had a question you didn't get a chance to ask. Thanks.